Hello everyone, in this video we'll be talking about SMS I/O control using CODESYS. So first I'm going to walk through the cabling connections of the SMS to the PLC, and then we'll connect the PLC to the CODESYS software. And finally we'll be creating a code that will allow us to control the movements of the SMS actuator. So let's get started with the cabling connections. What I have here is the PLC connected to the power supply. Over here I have my SMS. Down at the bottom of my SMS, I have a cable connected to the logic. So I'm going to get the other end of this cable, which looks like this. What I'm going to want to do is I'm going to want to disconnect this cap so that I can individually wire all of those connections to the PLC. First, before we get started, please make sure that you don't have anything connected to power. So first we're going to unscrew the bottom part of this cap. You can hold the top, the body, and you just have to unscrew here. From there, you're going to want to unscrew this black top. So you can hold the body part and you can unscrew the top. And you should get something like this. So down here at the bottom, I have all of my cabling. What I'm going to do with that is I'm going to take my screwdriver and I'm going to unscrew all of these screws around the cap. Now I have something that looks like this. What I did was I took some pliers and I exposed the wires a little bit. That way it would be easier to connect to the PLC. So now let's go ahead and look at the pinout of all of these cables so that we can know where to connect them on the PLC. So here I have the pinouts for the SMS and the CPXE PLC. Over on the left side, we see those 8 wires that we just disconnected. So starting with the white wire, it says that it can be connected to 24 volts DC. So over on the CPXE side, we see that 24 volts DC can be connected to pin 2. So here is a plotting diagram. We see that white is connected to 16 digital input pin 2. Next, the brown and the green can both be connected to inputs. So we see that inputs can be connected to 0 or 1. And I'll do so respectively. The brown will be connected to 0, the green will be connected to 1, both on the input slot. We see that the yellow can be connected to 0 volts or ground. So I'm going to go ahead and choose the fourth pin. Gray and pink can both be connected to outputs. So outputs are actually connected down over here at the bottom. We see outputs can be connected to pin 0 or 1. So I'll do so respectively. Gray is connected to the 8 digital output slot pin 0. Pink is connected to the 8 digital output slot pin 1. Blue says that it's not going to be connected, so we'll leave it there. And the red is going to be connected to 0 volts or ground. We had yellow already connected to 4, so we're going to connect red to the 16 digital input slot pin 5. So now let's see how that looks on the hardware of the PLC. Now we're back to the hardware PLC. Over here you can see those 16 digital inputs I was talking about and the 8 digital outputs. So let's connect the wires according to their pinout, starting with the white wire. We said the white wire is connected to 16 digital input pin 2, so let's connect it. One trick I like to do is go ahead and twist the wires so it's easier to insert into the pin. Now you're going to take a small screwdriver like this. You're going to go to the pin you would like to insert and you're going to press down. So I'm going to press down on the red in that slot and I'm going to go ahead and connect the white wire all the way as much as I can and I'm going to let go of the screwdriver slot. From there, I shouldn't be able to move the wire. Now I'm going to connect all the rest of these wires and I'll check back in once I'm done. Alright, now all my pins are connected, so I'm going to go ahead and power it on. We can see an LED is turning on, saying power is on. Now let's give it a couple of moments. Over on the SMS side, you're going to be able to see a yellow LED appear. That's not a bad sign. That means that it's receiving some power. The reason it's yellow is because the actuator has not been referenced yet. So in order to change it to a green color, we need to move it in and out and go ahead and have a set reference point. But we're going to do that with the software. So now that everything's powered on, I'm going to go ahead and connect it to my desktop laptop. So I'm going to use an Ethernet cable. I'm going to connect one side to the PLC. And I'll connect the other side to my laptop. Just a quick side note here, we have the logic power now connected to the PLC through the wires that we just connected. The other cable here is the load power, which is an M12 connector. That is these 2 wires that are connected to the positive and negative terminals of the power supply. The PLC is also connected to the power supply through these two black and dark blue wires. So what I'm going to do is I'm going to go ahead and get the connection to this power supply. I'll get the other end, plug it in so that I can provide power to this entire system. Now that we've gone through all the connections on the hardware, I'm going to go ahead and demonstrate how to connect the PLC directly to CODESYS, and then we'll run through a code that will allow us to control the movements of the actuator. So let's get started. Now that I have everything connected to the power, I have CODESYS opened here, and I'm going to go ahead and create a new project. I'll go ahead and name this CODESYS PLC SMS. And I'll have the template be my PLC. From there, I'm going to go ahead and click on the version of my device, which is 3.5.12, and I'm going to be coding in ladder logic. So we'll give that a minute to open. Now that that's opened, we can see over here on the left side a menu option. So we're going to go ahead and double click on device. I'm going to scan the network so that it can go ahead and scan to see if it finds our PLC. Click on that and press OK. Okay, so it found it. Now we're going to go over here to our CPXE system. Under actual configuration, we're going to scan. That way it can upload the actual configuration of our PLC. And we'll apply that to CODESYS. Okay, now going back to device up here on this tab, I'm going to go to PLC settings and I'm going to change this option to enabled to. That way it can always update our variables. Click on yes. Okay, now I'm going to log in to make sure that everything was connected. Once I hit run, we see green symbols over here, so we're good. Now I'm going to log back out and I'm going to go ahead and open our PLC program. Before we get started, I want to go ahead and lay out what I want the actuator to do. So I want the actuator to start at the state in position, and then it's going to shoot all the way out. So once the piston rod stretches all the way out and is at that state out position, I want to hold it there for 5 seconds. After those 5 seconds are done, I want it to go back to its state in position, and that will complete one cycle. I want this to happen 3 times, so 3 cycles. So I'm going to go ahead and get started on the code, and then I'll be back to explain where I got all the variables from, as well as the process of my code. Let's go ahead and take a look at the code now that it's complete, starting with the variables. So I'll like to go ahead and describe where I got the addresses from. So if we look on the left corner and we click on 16 digital input and 8 digital output options, and we locate the IO mapping, we're going to go ahead and see the addresses for all of the inputs as well as the outputs. This should be familiar based on the wiring configuration that we did earlier. So that's where I got all of my addresses for the inputs and outputs here. Now the HMI move in and HMI move out, those are Boolean signals that I created so that the code can go ahead and receive a signal to complete a particular process. And you'll be able to see that once I explain the ladder logic code. The rest of this here is also going to be explained with the ladder logic. So let's get into here. Before I go into the details, I would like to explain these two functions here, equal and move functions. Basically what I did here is I created, you can kind of think of it as steps. So this would be step 0. And once I complete this entire set of code, it's going to end at step 10. Now, rung 2 is not going to start until step 10 is complete, and so on and so forth. So I'm basically saying go through this entire rung before starting on to the next one. So starting at the top, I'm going to go ahead and set HMI move out to true, and it's going to immediately move the actuator out. Now, once that's done, it's going to make sure that status out is true, meaning that it's not in the process of being out, but it's actually fully stretched out, so the status out is true, and then it's going to hold there for 5 seconds. Once that's done, I created a control variable here called xtest1. And once that's complete, it's going to, so once it's reached those 5 seconds, it's going to move back in, and I'm going to go ahead and reset the move out position. That way, in the following cycles, it can go ahead and be reset already. So again, once status in is true, it's going to reset that control variable, reset move in, and it's going to go ahead and move out. And that cycle, I want it to complete 3 cycles. So here what I did is I implemented a counter. Now what I did, going back up here to the top, is I set the preset value to 3, meaning those 3 cycles. And so what's going on here is that if the current value is anything less than 3, it's going to go ahead and go back to step 10. However, if the preset value has reached the number 3, then it's going to go over here to step 50. So if it has to go back to step 10, it's going to complete all of this process all the way again, and it's going to check if the counter has reached the current value of 3. Now, if it has, it's going to go ahead and come down here to rung 6, and it's going to reset everything, and we're basically saying that the process is complete. So now that we have everything, let's go ahead and log in. Now that we're online, we're able to see the values of each of the expressions. Now, before going through the process, we do want to set that reference point on the CQ LED of the SMS. So basically, we want to change the LED from a yellow to a green color. The way we're going to go about this is we're going to hit run, and we're going to set our HMI move out to true. That way, the piston rod can go ahead and move out and set that reference point. So once I click true, I'm going to press on Control F7 on my keyboard. And now my LED has turned green. So I'm going to go ahead and do a warm reset. That way I can show you the timer as well as the current value increasing as the cycles increase. So I'm going to run it again. And I'm going to set my HMI move out to true. And now we can go ahead and see the timer running. Just completed 1 cycle. Now it's completed its 2nd cycle. After this 3rd cycle, it's going to go ahead and stop. And stop. So now we see that the status in is true. Thank you for watching this video. I hope it was helpful, and I'll see you on the next one.